In this video, I'm going to talk about arithmetic and geometric sequences. So sequences are just lists of numbers with some pattern, and an arithmetic sequence, that pattern is addition. So an arithmetic sequence is a list of numbers with a pattern of addition, so in which each term is the preceding term, so the term before it, plus some constant. So we're adding some constant each time to go from term to term. The pattern is that adding of some constant. And the constant that's being added each time is called the common difference. So it's called the common difference. I want to write two examples of arithmetic sequences, one with a positive common difference and one with a negative common difference. So for a positive common difference, and I'm just pulling these numbers out of nowhere, I'm going to start with the number 7. That's going to be the first term in my list. And I want to have a positive common difference of 3. So I want to add 3 each time. So to get the next term in my list, I'm going to add 3 to that, and it'll give me 10. To get the next term, I'm adding 3 to that, and it'll give me 13. And 13 plus 3 will give me my next term is 16. So what I did was I added 3 each time. And so my pattern is add 3 each time. And 3 is my common difference. Positive 3 is my common difference. So each time. For another example, I want to have a negative common difference. So I'm going to start with 10, just a random number, and I want to have a common difference of negative 2. So I want to add negative 2 each time. If I add negative 2 to 10, I get 8. Then the next term would be 6. The next term after that would be 4. So I'm adding negative 2 each time. That's what I'm doing. You could also say subtract 2, but in terms of arithmetic sequences, you want to get in the habit of talking about it as what you're adding. So I'm adding negative 2 each time. And that would make negative 2 my common difference. I want to derive the arithmetic sequence definitions. So I'm going to use this list of numbers that I have, 5, 9, 13, 17, 21. And I'm going to answer these following questions and then see if I see a pattern. Before I start talking or I start answering those questions, I'm gonna talk about how I can label each term in a list of numbers. So the way that I'm gonna label each term is a sub whatever position that number is in. So 5 would be a sub 1, 9 would be a sub 2, 13 would be a sub 3, 17 would be a sub 4, and 21 would be a sub 5. So that subscript is based on the position that number is in the sequence or the list of numbers that was given to us. And we need that in order to talk about what we're going to talk about. So what is the third term in the sequence in terms of the first term and the common difference? So first thing I want to do is I want to write a sub 3 because I'm talking about the third term. So the third term, a sub 3, which is 13. I want to talk about it in terms of the first term and the common difference. The first term that I have there is 5. So I could say a sub 3 is 5 plus, I'm adding something each time. So I know I could find a pattern where I'm taking the first term and I'm adding something to it. And then to find what I have to add to 5 to get to 13, I'm just going to go through 5 plus 3 I did to get to 9. Wait, I did plus 4, sorry. 5 plus 4 got me 9, and then 9 plus 4 got me 13. So I added 4 in between each term. That's my common difference. And how many times did I add 4 to get to 13 from 5? Well, I added 4 2 times. So I'm going to write 5 plus 4 times 2. For the next question, what is the fourth term in the sequence in terms of the first term and the common difference? So I'm looking for the fourth term, which is this term here, 17. And I'm starting with, so I'm going to say a sub 4 is equal to, the first term is 5 So 5 plus, I added 4 here, I added 4 here, I added 4 here, I added 4 a total of 3 times to get to 17. So I added 4 to 5 3 times. So 5 plus 4 times 3, I could write. For what is the fifth term in the sequence in terms of the first term? So I'm looking for a sub 5 here. A sub 5 is 21. And I'm taking the first term, I'm adding 4, adding 4, adding 4, adding 4. I added 4 4 times. So a sub 5 is equal to 5 plus 4, the common difference, 4 times, or 4 times 4. Now, I want to write a general rule. So what general rule could I write for the sequence for any term a sub n? So what if I wanted to find a sub 100? What formula could I use to do that? There's a pattern that we see here. If we write a rule in terms of the first term in our list. So a sub n, n being any number that we want it to be, 6, 7, 8, 9, 100, would tell us that the number that's in that position in the list. So a sub 100 would be the 100th term in the list of numbers. A sub n would be equal to, for all of these, I have the pattern that I'm talking about in terms of the first term, and I see the first term in all of these, and that's the first thing I see. So I can say that in a general rule, I would have 5 plus something. I would have 5 plus the common difference for a certain amount of times. And I want to say, in terms of n, how many times do I multiply 4 and add it to 5? So in this example, I was looking for the third term, and I added 4 2 times. I was looking for the fourth term here, and I added the common difference 3 times. And then here, I was looking for the fifth term, and I added the common difference 4 times. The pattern I see there is that I'm adding 4 one last time than the term position. So if I have a sub n, I would be multiplying 4 times n minus 1. 2 is 3 minus 1. 3 is 4 minus 1. 4 is 5 minus 1. That 5 came from here. That 4 came from here. That 3 came from here. So that's the pattern. And I want to know, is there a simpler way I could write this? And the simpler way that I could write this is, what I normally do when I see a constant and parentheses next to it, I distribute. So I'm going to do that and see if I could simplify this. I have a sub n is equal to 5 plus, if I distribute this 4, I have 4n minus 4. And then if I collect my like terms, I have a sub n is equal to 1 plus 4n. So this could be a simpler way of writing this with less terms. Where does that new first term come from? So where does this 1 come from? If I look in my list, there's no 1 here. But if I went backwards from 5 and I subtracted 4 to find the preceding term to 5, because I can do that, I would have 1. And that's where that term comes from. So 1 is the term before the first term. That's where it comes from. We also call it a sub 0. So this is a sub 0. If our first term is a sub 1, subtract 1 from that, and you get a sub 0. Then we have 2 definitions that we can write from for arithmetic sequences. And the one we just found was the explicit definition. It is the definition in terms of the first term. Okay. So our definition would be a sub n. We have 2 different ways we can write this. A sub n is equal to the first term, so a sub 1, which in our case, what we just did was 5, plus our common difference. So sorry, a sub 1, I'm just going to label this, is our first term. And then we're adding our common difference, so I'm going to label that D. the common difference times n minus 1. So D is the common difference. And then n is just the position number that you're looking for. The other way we can write this, so the simplified version that we found here, we could say a sub n is equal to a sub 0. So that's our new first term. A sub 0 is our, we say the term before the first term. And we add to that still the common difference. So 4 was our common difference. So we'll say D for a general rule. Our common, times just n. So we have dn. This is the easier, simpler one to use. You won't be given the preceding term. You'll have to find it yourself, but that's going to be the easier definition to use and the simplified definition to use. So I would recommend using that one, but you could use either. I'm just going to highlight this. This is the one we want to use. All right. The recursive definition is the definition in terms of the preceding term. So the preceding term is the previous term. So I could say a sub n is equal to a sub n minus 1. That would be the preceding term. Plus the common difference, which is D. Okay, so I just take the previous term and I would add the common difference, and that would get me my next term, and that's the recursive definition, which is pretty obvious. All right, in arithmetic sequences, we have constant growth. So we have a constant growth, something we're adding each time. We've seen this before. An arithmetic sequence is like a line, y equals mx plus b. The common difference would be the common difference is the slope, or m, and the term before the first term is the y-intercept, or b. If we look at this definition here, we just have it written backwards, but we have dn plus a sub 0. No, come back. I hate when it does this. Stop. I might have to leave and come back. Okay. So finding the rule. I have an example. I want to find the rule with this list that's been given to me. First, I'm going to find the common difference. So I know that from 4 to 11, I'm adding 7 each time. If I tell you this is an arithmetic sequence, I know I'm adding the same thing every time, and I can check that. But yes, to get from 11 to 18 and 18 to 25, I also added 7. The common difference then is 7. The term before the first term is what I want to find, because I want to use the explicit definition with the term before the first term, because that's the easiest, simplest way to write it. So the term before the first term, I'm going to take 4 and I'm going to subtract 7 to get -3. So the term before the first one is -3. And then I would write a sub n is, I take the term before the first term, so -3, and I add dn, and d in this case is 7. My common difference is 7 times n. Okay, for the second rule, you're 8, 5 to -1, I am subtracting 3 each time, or adding -3 each time. So the common difference is -3, and then I want to find the preceding term to the first term, so I'm going to actually add 3 going backwards, and that's going to give me 11. So 8 plus 3 is 11, So the term before the first term would be 11, and then the way I would write the definition would be a sub n would be equal to 11, that's a sub 0, plus d is negative 3 times n. In this next part, I'm going to, given a list of numbers, find the rule, and then use that rule to find a specific term. So I have the first one is 22, 32, 42. First thing I always want to find when I'm given a list of numbers is find what's the common difference. So when it's an arithmetic sequence. So I'm adding 10 each time here. That's what I'm doing. I'm adding 10 as I go from 22 to 32, from 32 to 42. My first term here is 22. So to write a rule, I can say a sub n is equal to 22. That's my first term. Plus, I have 10 times n minus 1. I could also find my preceding term to 22. So preceding that would be, the term before my first term would be 12 if I subtract 10 from 22. And I could also say another definition would be, so I could say, or a sub n would be 12 plus just 10 times n, the common difference times n. This is the one that I prefer to use, so I'm going to use this one most of the time from now on. I'm going to use that rule to find the 41st term. So I'm going to do a sub 41. So I'm going to do a sub 41, and that's equal to, I have 12, the first term, plus 10 times 41. And when I do that, I get a total of, if you do that on your calculator, or, I mean, you don't have to. You could do it on paper, but you would get 422. So 422 is the 41st term in the sequence. I also want to be able to find which term number is 762. So what term is 762? I have the rule a sub n is equal to 12 plus 10n. 762 is my a sub n. So I'm plugging in 762 here. I want to find what term number that is. A sub n is the actual term, and n is the position that it's in. So I want to find that position. I have 12 plus 10n. I'm subtracting 12 on both sides. That's going to give me 750 is equal to 10n. I want to write 10n is equal to 750 up here. I'm going to divide both sides by 10. And I'm going to find that n is equal to 75. So it's the 75th term is what I know from that. 762, it's the 75th term. All right, for the next list, I have 18, 12, 6. I know that I'm adding negative 7 each time, or I'm subtracting 6 each, sorry, why did I say that? I'm adding negative 6 each time, or subtracting 6 each time. The rule then I write is a sub n is equal to, well, I first have to find the preceding term, so I would actually add 6 to 18 to find the preceding term is 24. I say 24 plus, I have negative 6 times n, and that's the rule I'm going to use. I'm going to find first a sub 18. I want to find the 18th term, and that's going to be equal to 24 plus negative 6 times 18. And I'm going to get, when I do that, a total of negative 84. So a sub 18 is negative 84. I want to know which term number is negative 216. So I have the rule a sub n is equal to 12. Why do we keep doing this? 24 plus negative 6n. And I know a sub n is negative 216. So I'm writing negative 216 here is equal to 24 plus negative 6n. I'm starting by subtracting 24 on both sides. to get that negative 6n by itself. That's equal to negative 240 then. So negative 6n is equal to negative 240. I'm dividing both sides by negative 6 to get the n by itself. And then I find that n is equal to 40, which means it's the 40th term. Okay, I want you to try this example on your own. So the last example, I want you to try it on your own. The next thing we're going to talk about is arithmetic mean. So it's just means the average of two numbers. So the arithmetic mean is the average of two numbers. And I find it, the formula for it is x sub 1 plus x sub 2 divided by 2. So you add the two numbers together and then you divide by 2. That's how many terms you have. That's how you always find the average. Add all the terms you have together and divide by the number of terms. So an example of where I would need to find the arithmetic mean is if I have a sequence and I'm looking for the number in between. There are, to find the number in between 18 and 54, that's exactly in between them. I would take 18, add 54, and divide by 2. And when I do that, I'm going to get 36. So that's how I would find the number in between the two. Another way that I can do this, so if I'm missing two numbers in between, it's hard for me to use that average of two numbers formula. So what I could do is I could say, well, 12, I'm going to have to add d to 12 to get the next term, and then I'm going to have to add d again, and then I'm going to have to add d again. So I'm going to have to add d a total of 3 times to get from 12 to 138. So I could write an equation here that I can solve for d. So I have 12 plus 3d's gives me 138. I can subtract 12 on both sides. I'll get 3d is equal to 126. I can divide both sides by 3, and I find that d is equal to 42. So what I'm adding each time is 42, and then I can find my missing terms. So 12 plus 42 gives me 54. 54 plus 42 gives me 96. And then 96, if I wanted to check it, if I added 42 to that, I would get 138. Another example of a way you would see it would be a sub n minus 1 is equal to 16, and a sub n plus 1 is equal to negative 30, and I want to find a sub n. A sub n minus 1 is the term before a sub n, and a sub n plus 1 is the term after a sub n. So I know this is 16. I'm looking for the middle of that. This is negative 30. I could do this one of two ways. I could use the formula that I have here, or I can say, well, I have to add d 2 times to get to negative 30, and then I could write this equation to solve. I think the easier way of doing this is to use the arithmetic mean, so I'm going to do that. I have 16 plus negative 30 divided by 2. That's negative 14 divided by 2, which is negative 7. So I know this number is negative 7 here, and I could say a sub n is negative 7. And then the last thing that I want to do for arithmetic sequences is I want to be able to find the 15th term if I'm given the 16th term. So if the 16th term is, the 16th term and what the common difference is. If the 16th term, so a sub 16 is 9, and my common difference is 6, to get from a sub 15 to a sub 16, I would add 6. And that means that to get backwards from 9, or from a sub 16 to 15, I would be subtracting 6. And when I subtract 6, I would get 3. So a sub 15 is equal to 3. I would have to add 6 to 3 to get 9. So I'm using the recursive definition there. Then the next one is find the 42nd term if I have a sub 40 is equal to 10 and d is negative 5. So I have a sub 40, then I would have a sub 41, then I would have a sub 42. I start with 10. I'm adding negative 5 each time, so I'm adding negative 5 to that, and that's going to give me 5. And then I'm adding negative 5 to that one more time to get to the 42nd term, which would give me a 0. So a sub 42 is equal to 0. And then to find the 64th term, if a sub 4 is equal to 9 and d is equal to 2, this is a little more complicated. First thing I want to do is, well, I know that the definition will be a sub n is equal to a sub 0 plus dn. I know what d is, so I could fill that in already. But that's the only thing I know so far. To find, I could very easily find a sub 0 though. I know a sub 4, so I know a sub 4 is equal to a sub 0 plus 2 times 4, right? So I have, it's a sub 0 plus 8. And, sorry, I know what a sub 4 is, so I'm going to actually sub in what a sub 4 is. A sub 4 is 9. So I know 9 is equal to a sub 0 plus 8. If I subtract 8 on both sides, I can see that a sub 0 is equal to 1. So now I know a sub 0. I know my common difference. So I have a sub n is equal to 1 plus 2n. That's the rule. And then I'm looking for the 64th term. So I'm looking for a sub 64. I'm plugging in wherever I see n, I'm plugging in 64. And so my final answer is a sub 64 is equal to 1 plus 128. So now my final answer, sorry, is equal to 129.